Welcome to another tutorial on Matlab. In this tutorial series, we are looking into the plant modeling aspect of Simulink and Matlab. So how we can create different plant models using both the environment of Simulink and Matlab. In this particular tutorial, we will be looking into how we can create a scripted plant model, and from that how we can do the simulation for the real system. In this particular tutorial, we will see how the motor load concept works. So how a motor drives a load, and based on the motor rotation, how it is being impact. And understanding the same concept, we will be creating the state space equation, and from that state space equation we will be creating the MATLAB script which will run over a simulation time. So basically in this one, we will have a electrical motor, which is this one. This will drive a belt, and that belt will be driving a load. So this is the load, and this will rotate, and there will be some load that is there from the load side to the motor. So there will be some reaction force that will be exerted from the load side to the motor side, and the same can be represented in a simpler way, where we will have two types of system. This is a kind of electromechanical system, so combination of both electrical and mechanical system. So the load part is the mechanical part and the motor is the electrical part. So combining both of these components together, we will be creating this state space equation, plus we will be creating the script which will be simulating the system. So coming to the motor part, so here you can see in the motor we will have some inductive coils which can be represented with the help of La. So the coil inductance can be represented with the help of La, and this is the armature resistance which is there present in the motor. So basically this is related to the motor. Based on this applied voltage, which is the VA, which is the applied armature voltage, you will get a VB, that is the back EMF that is being produced in the motor, which will just oppose the terminal voltage. So that is why we have VA minus VB here, and the resultant voltage will contribute to the flow of the current in this particular circuit. So that's why we have the relevant terms for the current involving inductance and resistance. So here L di by dt represents the current from the inductance, and in the inductance part, and I into Ra represents the voltage. So this is the voltage part. So where V is equal to L di by dt. Start over. So in this particular model, you are able to see like in this particular model, you will be able to see VA minus VB equal to the right hand side part of the voltage, and here there is a voltage drop across the inductor, and there is a voltage drop across the resistor. So all those need to be summed up, and you will get this particular equation. And as you already know, like VB is the back EMF, and it is proportional to the rotational speed of the motor. So this term is shifted here, and KE is the constant which we will be using for the motor, and omega is the angular velocity of the motor. And later on we can again rewrite the same equation in the form of omega replaced with the theta dot, and you will get this equation. This is the electrical equation which is there for the electrical circuit that is present here for the motor. So this is the electrical part that we have designed now. Now let's go for the mechanical part and see how we can design that. So coming to the mechanical part here, now we have motor torque plus the load torque minus the loss that is happening due to the damping coefficient in the motor, equal to the rotational equal to the I, which is the inertia of the load, into the rate of change of angular motion or angular velocity. This is according to the Newton's law. So whatever the net force that is acting on this particular body, that will contribute to the motion of the body. So rearranging these terms, we will have this term on one side and the other terms on the other side. So we are just shifting these terms to define TL. So solving these equations, you will get the final equation from the mechanical side. This is a mechanical system equation. So now the time comes, we need to combine those two equations, which are the mechanical part and the electrical part. So combining both, we will have the state space equation. So if you see this state space equation, which is dx by dt equal to ax plus bu. So this is the final equation of the subsystem. So you will have ax plus bu. So here, this is the part A, this is dx by dt, and this is x, and this is the input. So here, this is the input, the applied voltage and the torque that is produced on the load side. Load also we can change, like we will put more stress on the load side so that the motor will try to rotate the shaft with a higher Newton of force. So that we can control with the load, which will be just opposite to the torque that is produced by the. So this is how you can get the state space equation for a electromechanical system, and the same we will be designing in a scripted environment in the Matlab scripting in the coming tutorial. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. It will help us to improve your experience of learning Matlab in this channel. Have a great day ahead. Thank you.